Well, g'day, Max here again, welcome back to the shop. So just a bit of an interruption this episode on the lathe we've got over there, the maintenance and modifications. I've just had a couple of other things which I've had to slip in first. So one of them we'll swing over and we'll do this little job on the old south bend. It's just a part for a penetrometer. So a penetrometer is it's like a compaction testing tool. So it's basically it's a 5/8 diameter steel rod with a 9 kilogram weight. You drop up and down, and you're supposed to count the blows, and the rod going into the ground is only supposed to go in the ground a certain amount, and that's how you test your compaction. So we need this up and running, this penetrometer. I'm just piecing one together out of old bits and pieces for testing our compaction up on the new shock pad. So as I said, we'll do that on the south bend as the other lathe's still out of commission. Now, we had a bit of a win with regards to the Bridgeport, as Hong Fuck Wong there behind me is starting to give me the shits with all the slop and the spindle and all of that. So I think I might have mentioned before, she's due for a major overhaul. We're going to pull the spindle out, pull all the head. We're going to strip the whole machine. We're probably going to either make a new spindle, a new quill, or re-sleeve this one. I'm not sure which way we're going to go till we get it stripped down. So the Bridgeport, so that's up and running now. I've only just got that up and running, so we'll swing you over and take a look at what we had to do. Oh, okay, we're over in the sheet metal department today. So what we're making up is we've cut this piece of plate out. It's just 2mm. So on this plate we'll mount our two braking resistors for the VFD, and I have this cover plate. It's a bit of stainless steel perforated plate, so I'm just going to fold up a little box, and that will sit over the top protecting the resistors, and so nothing touches the wires or anything like that. So I've got this little set of shears that I use to cut all my sheet metal, and it's just a little set here that bolts up in the vise, and yeah, very effective. I don't know what the make is, I can't read the sticker on. They're donkey's years old, but no, a very effective set of shears. They just mount up in the vise. So we have our perforated plate mounted up in our little folder. So this is like a 3-in-1 little thing, this, so you can roll the rollers up the top. You can bend like a press brake, as we're going to do here, and underneath it has a guillotine feature as well, but you can it's only for very light gauge materials. So, but it's an old cheapo Chinese thing. It does the job. It's better than nothing or bending it over the edge of the bench. So we'll see how it goes. Just on that fold, okay. So we've just got to go a little bit more on that one. It really should be bolted to the bench, and then you can give it a bit of welly, you know, on the handle without the whole thing going arse up. So that's looking better. So I'll continue folding this up into the box, and I'll bring you back. Okay, so mounted on the wall of the shop we've got our VFD, and then below it we have two braking resistors. So I did make up a cover, as we've seen earlier on, so this will cover up the braking resistors so we don't get zapped and it can still breathe through the perforations. So we have her all powered up. I've just got to finish off some, put the covers back on and all of that. We have left the forward reverse switch on. Normally you don't, but I didn't want to pull too much of the wiring apart on this, as it's going to be reconnected to 3-phase once we're in the new shop. So to control it, we have this little handheld jigger here. So if I want to turn the mill on, we hit the green button. When you all would have seen VFDs before. So that'll build up some hertz, whatever it is, it counts. So we have some spindle rotation. Now you can control the spindle rotation with the little knob on the VFD, but I think I'm preferring to keep the motor running at its normal revs and stick with the controller on here, so I can alter our speed here, speed it up, slow it down. Switch it off. But we do reverse it here, so when we drop the Bridgeport into back gear, we hit the reverse and then go again, and she'll start running in reverse. Eventually it does. It takes a bit of time to build up, but it gets there. The main thing is it's up and running and usable. Now, only having that VFD won't allow us to operate the power feed, which is a 90-volt DC motor. So I can just put up with that, hand feeding for now. I may even get a transformer, something to run it. But as I said, this is just until we're into the new shop. At least we can still run it, we can use it now. So that's the main thing. So Hong Fuck Wong there. Should be a good thing again one day, but as we said, she's due for a full rebuild. So what we'll do, we'll swing around, we'll get set up in the south bend, and we'll start machining this anvil we have to make. Okay, one other thing with the Bridgeport, I'm going to make a little bracket so the controller will just sit up there. It's right out of the way. You do see a lot of these mills fitted with VFDs, and people take the switch off, then they've got this big box sitting there, and that's something I definitely don't want to do, because I feel if you may be doing some job where you might have the head completely cranked over, and having that box on the side does restrict the capacity of what you can do with the mill. Tooling's we have to get a bit of tooling, so we're limited at the moment. We've got a drill chuck, old brick drill truck, and my old ER32 number 3 Morse taper on an adapter, so I'll just drill this adapter out and probably put a longer drawbar through or something like that. That'll get us going anyway till I can scrounge up some more tooling. That's R8. So it's just a basic job here for the south bend. So our anvil, we just face off both ends, drill and tap 5/8 UNF all the way through, and that's it done. Lock our carriage off. tool up just a fraction below centre here. Just raise it up, the old lantern tool post. See what that looks like. A lot better. A little bit to come off as the old bandsaw blade is a bit tired and cut on a bit of an angle. Centre drill to get things started. Not quite like the other lathes when we have to slow things down. Now do a different pulley size. Like that. I do miss not having flood coolant though. I'm glad I don't have to do this on a daily basis. It's only a 2-inch stroke on this tailstock, so only with 3. So next step, we'll get it set up and bored out for a tapping size for 5/8 UNF. Okay, so we're off for the old lantern style. This is all the original equipment that came with this lathe back in the 50s. And on with this one. Just get it lined up a bit. We can shorten that bar up a bit, that one. Keep it as short as possible. It's only a very tiny bar. We're only doing a tiny hole. And we'll leave it on the slow pulley because it's got a fair bit of overhang on this little bar, so we'll see, take a trial cut and see what happens. That's 20 thou off the diameter. Handling that okay. Okay, well, I'll get that board out to the tapping size for 5/8 UNF. It's been a long time since I've used like this tool post. I haven't used it for donkey's years, as you can probably tell by the state of it. Needs a good clean, as does the whole lathe. Now this is the lathe that I actually learned to machine on when I was 14 years old, so, well, that's 40 years ago, so she still does the job, the little bits and pieces. So. Okay, we've got our tapping head set up. This is an old arch one that I've had for donkey's years. The only problem with this tapping head is, apart from it needs pulling apart and servicing, I have to check the clutch on it. The tang is broken off the Morse taper, so we'll see how it goes without that, you know, so hope for the best. The tang, okay, it is designed just for ejection purposes, but it does actually prevent the taper from spinning if anything grabs. So the only tap I have is a secondary tap, so it's quite sharp, so we'll see if we will push it through in back gear and see what happens. Okay, we're in its lowest back gear speed. There are a couple of teeth missing off the back gear, so hopefully she won't lock up. So the cutting fluid on it, we'll see how she goes. Oh, she nearly made it through to the end before she locked up. It's alright, we'll put a shifter on it and continue on. Okay. She's done well to get it through that far. what I'll do is I'll put it back in the tapping head. We'll just run her in and out a couple of times. Oh, there you are, the little lathe that could. Probably should have backed it off a few times in the first place. Well, we've run out of clearance on our tapping head. Tap's not quite long enough to fit in the tapping head and go all the way through the hole. So I don't think we've got that far to go. Power it up. Always have your finger on ready on the off button when you do this sort of thing. It's not recommended, but I know that the tap was getting quite free in there, so okay, out of back gear. Reverse it. So that's all completed. We've got a nice thread in there now. So all that's left just to face the other side off square, and this part's done. Okay, this is our repaired Perth sand penetrometer. and that's its proper name, a Perth Sand Penetrometer. This is for testing soil compaction. So I think the maximum granular size of the soil is 2 millimeters or so. So in essence, it's basically like a slide hammer. So this weight drops down the top half. It must drop 600 millimeters before it hits the anvil and drives this rod into the ground. Now on the rod there's graduations 150 millimeters apart up to 300 millimeters. And so you drive the rod into the ground to the first graduation there, 150 millimeters, and then you count the number of blows it takes to drive the rod in the ground, a total of 300 millimeters extra. So according to your soil compaction specifications, that will determine how many blows and also the depth the rod goes in. So this is a shortened rod. This is a much shorter rod than normal. It's a broken one that I've just shortened up, so it will do for what we have to do up there. So we might take it outside. We'll give you a quick test run. Okay, so I'll give you a quick demo of how this thing operates. So what we do is we knock it into the ground till the first 150 mil mark comes up. And we count the blows till it gets to 300 mil extra. Hit a tree root. I'll try a different spot. Okay. Well, there's 2 blows to go 300 mil. So when we're up at the new shop site on the pad that I'm doing there, it should take 7 blows to get it down 300 millimeters. So we'll see how we go once we get up there and give it a good run.